Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about the laws of logarithms. So there are three basic rules or laws for logarithms. The first one is called the product law or product rule, which says that log with base a of m times n. So if we have the product, then this can be expanded or this can be written as log base a of m plus log base a of n. So we can split that into a sum. The next law is the quotient law. If we have a log base a of m divided by n, then this can be expanded or we can split this as log base a of m minus log base a of n. Similarly, there is a power law which is log base a of m to the power of p. If we have that, then we can drop this down to the front. Okay, so we can write p log base a of m. So we can bring that power down. So these are the basic three rules that we are going to use in this section. So let's go ahead and use those basic rules and evaluate the given log. So if we look over the first one, so we have log base 2 of 4 plus log base 2 of 8. That means we have a sum here. So it looks like this one right here, this law. So this can be written as, so we can go backward or we can go over here, and then we can write this as log base 2 of 4 times 8. So this gives us log base 2 of 4 times 8 is 32. And then we know that log base 2 of 32 is 5, which means 2 raised to 5 gives us 32. Now, if we look over here in the second one, what we have here is we have log base 5 of 250 minus log base 5 of 2, which means it looks like this one right here, the second one, okay? Like this. Now here, we can use the quotient law here and we can change that difference into a quotient. So this can be written as log base 5 of 250 divided by 2. So which means this is log base 5 of 125 and then this equals 3 because 5 cubed is 125. Similarly, the third one here is the third law, which is the power law. Okay, so if we have log base a of m to the p, then we can bring that power down here. Okay, so here we have natural log of e to the fourth. So that means this 4, we can bring it to the front here. So that equals 4 times natural log of e. And in the last section, we discussed about this one. So natural log of e is 1 because natural log means it's the log with base e. And if we have e here, so if we have the same number here as the base, then that equals 1. So natural log of e is 1. So 4 times 1 is 4. So these are the values for the given expressions. Now, let's use the laws of logarithms to expand the given expression. So we have given single log. What we are going to do is we are going to use these laws and we are going to expand this, okay? So if we look at the first one here, if you look over here, so we have a numerator divided by denominator. So it looks like this one, the quotient law. So that's what we are going to use the first. So we have log base a of m over n equals log base a of m minus log base a of n. So we are going to use the same thing here, okay? So the numerator is m, denominator is n. So this equals log base a of m means the numerator, which is x cubed y to the 7th minus log base a of z to the 5th. Now, with this one right here, this one, we have a product. So we have x cubed times y to the 7. That means we can use the product law for that. So that equals log base a of x cubed plus log base a of y to the 7th minus log base a of z to the 5th. Now the final step, we are going to use the power law, this one. So if we have a power, we can bring it to the front. So we can bring this 3 right here, we can bring that 7 right here, and then we can bring that 5 down here. Okay, so that equals 3 log base a of x plus 7 log base a of y minus 5 log base a of z. So this is the final expression. That's how far we can go. Okay, now let's look at the second example that we have here. So let me separate this. So now here we have that cube root. So first what we are going to do is we are going to change that radical into exponent. Okay, so if you have nth root of x to the m, this can be written as x to the m divided by n. That means we are going to divide the exponent here inside by 3. So this equals log base a of x to the 2/3 y to the 4/3 divided by z to the 5/3. Now we can use the rules of the laws of logarithms. So the first one, we are going to use the quotient law, which means we have log base a of x to the 2/3 y to the 4/3 minus log base a of z to the 5/3. Now, here again, the first one here, we have a product, so we can use the um, product law here. Okay, so that equals log, sorry, let me change the color. So this equals log base a of x to the 2/3. Then we have a product, so that means it changes to a sum. So plus log base a of y to the 4/3 minus log base a of z to the 5/3. Now we are going to use the power law. That means we are going to bring those exponents here to the front. Okay, so this equals 2/3 log base a of x plus 4/3 log base a of y minus 5/3 log base a of z. And that is the final expression that we have. Let's look at one more example for the expansion. So now here, again, what we are going to do is first we'll change that radical in the denominator into an exponent. So this can be written as log. So we don't have a base here, means this is common log or base 10. So we don't write base for common log. So log of 15 x to the 15th y to the 8th divided by, this can be written as z plus 5 to the 1/3. So we'll change that to an exponent. And then first we are going to use the quotient law, because we have the top expression divided by the bottom one. So this equals log x to the 15th y to the 8th minus log z plus 5 to the 1/3. Now again, here in the first one, we have a product. Okay, so we are going to this is 1/3. 1/3. Okay, so we have a product here. So what we are going to do is we are going to write that as log x to the 15 plus log y to the 8 minus log z plus 5 to the 1/3. Now using the power rule, we can write this as 15 log x plus 8 log y minus 1/3 log z plus 5, and that is the final expression. Now we did a couple of examples for the expansion. Now we are going to do the reverse. Okay, so we have the expanded expression given. Now what we are going to do is we are going to condense this, or we are going to write this as a single logarithms. Okay, so let's go ahead and do the first example. So when we are applying this rule, if you look over here, when we go from sum to product or difference to quotient, what we need is we should get rid of any coefficient that we have before log. Okay, so if we have any coefficient, first we have to use the power law and we have to put them in the exponent, and then only we can use the product or quotient law. Okay, so something that we really need to pay attention here. So we have a 3 here and we have 1/3 here. First, we need to take them to the power and get those coefficient free. Okay, so let's go ahead and do that first. So this equals log base b of x cubed minus log base b of y plus log base v of z to the 1/3. So after that, what we are going to do is we'll combine this. Okay, so let's start from the left. So we'll combine the first two and then we'll combine the next one. So if we just look over here, we have a difference. That means we can use the quotient law. So when we have a difference, we can write that as a quotient. So that's what we are going to use here. So log base b of x cubed divided by y plus, now this can be written as log base b of cube root of z. Let's write it that way. Okay, now if we look at this, we reduce from 3 log to 2 logs. Now we can combine these two using the product law. So we have a sum, that means we can combine them as single log by multiplying the quantities inside the log. So this becomes log base b of, so we'll multiply them, so we get x cubed cube root of z divided by y, and that is the single log that we are asked to find. So let's look at B, next question here. Again, we need to do the same thing. If we have any coefficient, we need to use the power law and we need to put them here as an exponent. All of this coefficient, we need to move them up. So this becomes log base 5 of z to the 10th plus log base 5 of y to the 17 minus log base 5 of x plus 11 to the 1/2. Now let's go ahead and combine the first two using the product law. So that becomes log base 5 of z to the 10 times y to the 17 minus log base 5 of, so we can write this one as square root of x plus 11. Okay, and then using the quotient law, we have a difference, so we can combine them together as log base 5 of z to the 10th, y to the 17th, divided by square root of x plus 11. And that is our single log. Now let's see where we are next. So one more example here. We are going to combine this into one log again. So again, it's the same process. If we have any coefficient, we need to put them here. We need to take this over here, and we need to take this over here. Okay, so this becomes natural log of x to the third to the squared. Okay, so now plus natural log of y to the 1/2 minus natural log of z to the 5th cubed. Now this becomes natural log of x to the 6th plus natural log of square root of y minus natural log of z to the 15th. Now let's combine these two first. So that becomes natural log of x to the 6th times square root of y minus natural log of z to the 15th. Now using the quotient law, we can write this as natural log of x to the 6th square root of y divided by z to the 15th. And then we got the single log. Now, one final thing here, the change of base formula. So when we are finding values of log, so for example, if you have to find log of, let's say 20, we can just put this into the calculator because the base here is 10, which means it's a common log. So we have a key in our calculator where we can just plug this in and find the value. Similarly, if we have natural log of something, we can also use calculator to find this. But in some calculators, the recent one, the new model calculator TI-84 and the newest version, they do have the function where we can use any base. Okay, but some older calculators, they don't have these other bases. Okay, so they can only calculate natural log or the common log. So in that case, what we can do is we can change the base of a given log. If we have any other log than common log or natural log, we can change the base and we can write that in terms of base 10 or base e, which is natural log, okay, or any other basis. So if you want to change it to a different base, we can do that. So there's a formula for that. So the formula is right here. So if we have log base b of m, then we can write this as log of base a, means any desired base, whatever base you want to take it to. So for example, if I want to take that to base 10, so it's log, okay? So log of the desired base of m divided by log of the desired base of b. So this way, if you don't have that key in your calculator, you can still evaluate this log, okay? So let's go ahead and try this on. Let's change this to common log and natural log, and then put it into the calculator and find the value. Okay, so first let's go ahead and change this to a common log. So if we are changing this to a common log, then we write log 10 divided by log 5. Okay, and then if we put this into the calculator, you can put it into your calculator, but if you put that in your calculator, this is what you are going to get, approximately 1.43. Now you can also do this. You can put this, change this to a natural log. So you can write natural log of 10 divided by natural log of 5. If you do that, you still get the same thing, 1.43. Similarly, this example here, we can change this to log base 10. So log of 25 divided by log of 9. And then if we put this into the calculator, we get approximately 1.46. Okay. Similarly, if you put that, change that to a natural log, so natural log of 25 divided by natural log of 9, and then we still get the same thing, which is approximately 1.46. Okay. So this is the something that you can use if your calculator doesn't have that function to use any log base. Okay. Now the final property we usually like in the examples we use those three properties, but there's one very important property that you might need in the future. Okay, especially when you head into the calculus, we use this property. So this is very simple. We have a base a raised to log base a of x. So if this base here and base of the log match, then the value of the whole expression is just x, or whatever that number is. For example, if I have 2 to the log base 2 of 10, then this equals just 10, because this base is same as the base of the log. That means the value is just this quantity here, or that number there. Okay, so this is another property that you might want to use or you might need later. So that's all for this video. I'll see you again in the next video with more examples.